रिएक्टिविटी सीरीज, इसके ऊपर है बेटा रिएक्टिविटी सीरीज के ऊपर। अब आपको पता करना है कि कौन किसको डिस्प्लेस करेगा, तो आपको रिएक्टिविटी सीरीज क्लियर होनी चाहिए। जो दिखाता है वो रिप्लेस कर जाएगा, सही है कि नहीं? बताओ कौन करेगा किसको? One comment I'm receiving. Hello, everybody. Am I audible? I hope I'm audible here. Sorry for a little bit of disconnectivity from last 2-3 days. Actually, you must have, if you have seen the last few lectures, then you know that I was not keeping pretty well. So that was the major reason of me not taking the lectures. But I hope now you understand. But one student is writing, sir, please continue PYQ series. It was very helpful. Boy, PYQ series is being continued. Don't worry about it. Only last week or last 2-3 weeks, because of JEE Main's first attempt and a few more indulgements, we could not take our lectures properly, but it is being continued. Tomorrow also I'm going to take ellipse PYQs for you, which I could not, which were planned for last week only, but my throat was not keeping well and I really wanted that my throat gets better, so that was the reason I could not take the PYQs of ellipse in the last class. But yeah, from this class we'll be continuing, and today we already have one session of PYQs only, right? No, not PYQs. Today we have 2025 aspirants. So in RRR series, in the restart series, what we are just doing, we are revising all the important concepts of important chapters throughout, and after this we are also solving the questions in our practice sessions, which will be there on Unacademy platform. But in the last session I logged in, I was there, I waited for more than half an hour or so, but hardly anybody came. Only 1-2 students came, they asked their questions, they went. So there is no point in taking the practice session if you guys are not coming. So I'd request again, the link of the practice session is going to be there in the description with date and time. If you want that time to be changed, you can comment, sir, please change this, change the practice session time to night or to morning, whatever. And even 2-3 students says that, no, I'll take that session for you. We can have a brainstorming session, we can discuss many questions, because you know, over here we have kind of a restriction that we cannot stretch it for more than 4 or 5 hours, right? Because over here we cannot practice, because discussion cannot happen. In the comment box you'll come, you'll go, that does not happen. That's why there are practice sessions which are being conducted on the platform. So for that, I'd say enroll yourself. They're completely free. There is no fees, there is no payment or anything in that. They're completely free. You can interact with me, you can talk to me, we can have a video call on the platform itself. We can discuss many things which cannot be discussed over YouTube. So here I'm just going to tell you all the concepts, all the type of questions, all the varieties you need to know for your JEE Main second attempt and even for advanced. Apart from this, the practice which we are going to do is going to be in the practice sessions which are on the platform. This I'm reminding everybody again, right? If you watch the video later also, remember that practice session is being taken on the platform. The first practice session also of of sequence and series and quadratic equations, that also we can take once again if you want, right? We can reschedule it if you want, not a problem at all. This practice session of binomial theorem, again I'll be taking on Friday morning or evening. You can comment, you can put a comment, sir, please take the session, practice session in the evening or in the night, when we'll be able to be available or we can indulge in the practice session. So that and all you can comment, but do come for the practice session, okay? That's only for you guys, that's planned and prepared only for you guys. So there actual practice can be done and actual discussion can be done in those practice sessions. All right, so binomial theorem, another major topic, very at least two questions are coming in every attempt, right? We have seen at least two questions this year 2025, except one or two attempt. In every attempt we had at least two questions in every session, right? Morning session, evening session, in all the 10 sessions, in every session we have seen at least one or two question, right? Two question I would say, because in many of the sessions there were more than two questions also from binomial. Either they were involving something of binomial or straight away binomial theorem questions. Very easy but a little bit calculative chapter it is, right? You just need to practice it, nothing else. Just practice it, and this is a very scoring chapter. One by one I'll tell you all the concepts. I'll show you the types of questions which are made from those concepts, how to solve those questions. Everything we'll discuss once again in this session, right? Once we have already done on the channel, but for specifically for 2025 aspirants we are doing this again. So let's start. It starts with the simple notation which we generally learn in permutations and combination, but it starts from here, right? Choosing R things from N, right? That's it. This is binomial theorem's expansions coefficient, main coefficient, NCR. What do we mean by NCR? N factorial over R factorial multiplied by N minus R factorial, right? This simple formula, for example, if I have 4C, or sorry, let's take a bigger one, 7C4. So this will just be 7 factorial, which is N, divided by 4 factorial, which is R, and N minus R, that means 3 factorial, right? 7 minus 4 factorial, so multiplied with 3 factorial. Now solving this is also very easy. You know 7 factorial means 7 multiplied with 6 multiplied with 5 multiplied with 4 multiplied with 3, and it goes on like that. 4 factorial means 4 into 3 into 2 into 1. 3 factorial means 3 into 2 into 1. So you can cancel the terms. So in the numerator you will have 7 into 6 into 5 into 4, because after 7 into 6 into 5 into 4 into 3 into 1, or we can say 7 into 6 into 5 into 4 factorial divided by 4 factorial multiplied with 3 factorial. So now 4 factorial and 4 factorial will get cancelled, right? Because after 5 it will be 4 factorial. So this is how you solve it. Then you can simply do 7 into 6 into 5 divided by 3 into 2 into 1. So 2 3s are 6, 3 cancel. Finally you will have 35. Solving this is not difficult. It just looks complex, but it is not that calculative also. You just need some amount of practice. You can see a few examples. 8C3 is 8 factorial divided by 3 factorial multiplied with 8 minus 3 factorial, which is 5 factorial. 10C2 means 10 factorial divided by 2 factorial multiplied with 10 minus 2, that means 8 factorial. And solving these, you know how to do this. Just practice a little bit. Without practice, this chapter is difficult, right? If you just practice means just like while you're listening to the lecture, that time only start solving, and you'll be able to, trust me, you'll be able to solve a lot of questions if you keep solving this particular session along with me. Even if you're studying this chapter for the first time, you'll be able to do a lot, achieve a lot. Okay, now some major things which we need to know. Some more factorials are there. 8C5. Now if we observe, this particular formula is very simple and is very important to remember, right? We always should know that NCR will always be equal to NCN minus R. They'll always be equal to each other. If you solve it, then also you can easily prove that NCR will be equal to NCN minus R. We'll be doing some questions where you'll realize that how we can prove it, but it's better that you remember. That means, it simply means if I'm writing 8C5 or I'm writing 8C8 minus 5, that means 8C3. Both of these will be equal. You can check. This will be what? 8 factorial divided by 5 factorial multiplied with 3 factorial. What will be this? 8 factorial divided by 3 factorial multiplied with 5 factorial. 8 minus 3 is 5. 8 minus 5 is 3. So both are going to come equal only. With this example, you can easily realize that NCR will always be equal to NCN minus R, and it is very applicable, very useful. Sometimes directly you'll have to observe in the question that these two are equal. There is nothing to worry about, right? 10C8 will be equal to 10C10 minus 8. That means 10C2. 8C3 will be equal to 8C5. That means 8C8 minus 3. 5 is 8 minus 3. This is one thing. After that, some important results. How to remember them? First result is this one. Please pay attention at this and try to write it right now. Write it in your notebooks wherever you are. Even if you remember, even if you have studied, just write it once more on your own so that this gets stuck. Now, how to remember it? NCR plus NCR plus 1. Now, observe here, N and N are same. R is increased by 1. Result of this will be N increased by 1, C, R plus 1. For example, if I am writing 8C3 plus 8C4, right? Now 8 and 8 are 8, R and R plus 1 are, R is increased by 1. So my answer will be N increased by 1, that means 8 plus 1, 9, C greater 1, which was R plus 1, this was R plus 1, so 9C4. Now quickly tell me what will be 7C3 plus 7C4. Quickly calculate it. It will simply be 8C4. N increased by 1 and R the greater one. This is how you'll have to remember it, and this quickly you should be able to write it. So write 2-3 examples on your own. You'll be easily able to remember. Very, very important result. The next one, NCR over NCR minus 1, which is just N minus R plus 1 CR. N and N are same. R is decreased by 1. So basically, if I have 8C5 divided by 8C4. Now, if you solve it, you can easily solve it because these are numbers. But if we have variables, then we should remember this formula. This will be nothing but N minus R plus 1. That means 8 minus, which was R, the upper one. R is this one, the upper one. N minus R plus 1, that means 8 minus 5 plus 1 divided by R, which was R again 5. So this will be nothing but 4 by 5. This easily you'll have to remember it. 8C NCR over NCR minus 1. R is decreased by 1. Right? Same N. N is same in both the cases. Here also N is same. R is decreased by 1. It will nothing between. So R is going, N and R both are in the upper numerator one, the numerator term. It will simply be 8 minus 5 plus 1 over 5. That means N minus R plus 1 over R. Remember this formula, practice 2-3 times, write some random terms, and then you'll be able to remember it very, very easily without any problem or without any trouble. Next one, if NCR is equal to some NCY, suppose NCR is equal to some NCY, two coefficients are equal, right? In these cases, in this case, we'll simply say either R is equal to Y, or this should be X actually. NCX is equal to NCY. Either X is equal to Y. This can be only in two conditions, that your NC some X is equal to NCY. Two coefficients are equal, or these two are equal where N is same. This can happen only in two cases. Either your X should be equal to Y, both at X and Y are same. Either that can be the case, or because of the property which says NCR is equal to NCN minus R. Because of this property, it is also possible that even this will be same if X plus Y is equal to N. Because you see, R plus N minus R is equal to N in this. So this can also happen. These two can also be equal if X plus Y is coming out to be equal to N. And why? Because of this particular property which we studied in the earlier slide, right? So important property, very important property. Sometimes they'll compare, you'll have to compare two binomial coefficients with different R terms, right? In that case, you'll have to consider two conditions. Either X and Y both are equal, or the sum of X and Y is equal to N. Okay. This is one thing. Now, one more notation, very important notation. NCR, these are all important things about NCR notation. Keep writing them down and keep creating 2-3 examples of your own so that you can easily remember them. So now see, we learned this NCR plus NCR plus 1, which will be equal to N plus 1 CR plus 1. Now this can be used in many scenarios. Remember it like this, as I told you, right? This is this one only, A1. NCR plus NCR plus 1, which will be equal to N plus 1 CR. sorry, n plus 1 C r plus 1. Now if you see A, the observation number A, n plus 3 and n plus 3 are same. This is how you have to remember it. The upper term is same, n and n are same. Here n plus 3 is same. R is increased by 1. Here also R is being increased by 1. What will be the result? The upper term increased by 1, that means n plus 3 increased by 1, that means n plus 4 C, the greater R, right? So R plus 1, that means the greater one, C, the greater one, right? Now over here 2 and 2n are same. R plus 2 is increased by 1, so 2n will be increased by 1, C, the greater from R and R plus 1. So R plus 2 and R plus 3, greater one is R plus 3. This is how you should remember it. This is how, this quickly you should be able to comprehend it. Yes, I'm Johnny. I know there are only two. Thank you for being one of them. What else can I say? All right, next one. Next one. This also we learn, right? This also we learn. This also is very useful, very applicable. This also is very useful and very applicable. You have to remember it as it is. You can prove it also if you want. N factorial upon R factorial into n minus R factorial. This is going to be. Here what we will have, n factorial upon R minus 1 factorial multiplied with n minus R minus 1 factorial. Right? So it will be n minus R plus 1 factorial. Now if you solve this, you'll exactly get this, because all these terms, n factorial is getting cancelled already. This will go up. R factorial you can write as R into R minus 1 factorial. This will go up. I'll show you. So this will become n minus R plus 1 factorial multiplied with R minus 1 factorial divided by this term will come, which will be R factorial. Now this R factorial I can write as R into R minus 1, R into R minus 1 factorial. Why? Because 4 factorial is what? 4 into 3 into 2 into 1. So 4 factorial can also be written as 4 into 3 factorial, right? If I want to write n factorial is nothing but n into n minus 1 factorial. Why? Because 7 factorial can also be written as 7 into 6 factorial. Now 6 factorial will be 6 into 5 into 4 into 3 into 1. So that way, okay. Now that is why these things are getting cancelled. So what are you remaining? N minus R plus 1 factorial will be n minus R plus 1 factorial, into multiplied with n minus R factorial. N minus R plus 1 minus 1 will be what? N minus R only, right? Which we already have in the denominator. So R multiplied with n minus R factorial. This will get cancelled. Finally, what will you have? N minus R plus 1 divided by R. It's proof anyway you will be able to do. This much effort only for 2 people. But it's not only about 2 people who are watching right now. Obviously, that also is an effort and that is totally justified. But even if somebody watches it later, if somebody has a difficulty in understanding in Hindi, in English I'm trying to do my best and explain as much as I can. So that's the motive. The motive is not to create a lot of crowd on the channel right now. It's just to support the English understanding and English speaking people as much as we can for 2025, 2026 and 2027. All right. So that's the motive, right? So proof and all you'll be easily able to do, but it's better you remember the formula. For example, how to remember? N and n are same, R is decreased by 1. N by n plus 2 same, R is decreased by 1. What will be your result? N minus R plus 1. What is n over here? N plus 2 minus R plus 1 divided by R. That's it. R is the upper one. So what will this become? 2 plus 1, 3. So n minus R plus 3 by R. Right, what will this become? 2n same. What is n over here? 2n. Instead of n we have 2n. So 2n minus the upper one. R is the upper one, right? R is the upper one. R is being decreased by 1. 2n same. R plus 4 is decreased by 1. So R plus 3. Now 2n minus R plus 4 plus 1. This is how you'll have to write. R is the upper one divided by R, which is R plus 4 only. So 2n minus 4 plus 1 minus 3, 2n minus R minus 3 by R plus 4 will be your answer. This quickly you should be able to apply this particular formula, which is very very handy, which is very very applicable in many of the questions. Now 2nc5 is equal to 2nc7. Then find 10cn. What does this mean? Told you, right? If ncx is equal to ncy, it can happen only in two cases. Either x and y both should be same, or where x and y both are not same. So that means the sum of x and y, that means 7 plus 5 should be equal to n, which is 2n in this case. So 7 plus 5, 12, n will be equal to 6, and we can simply find 10c6, which will be 10 factorial divided by 6 factorial multiplied with 4 factorial. So 10 into 7 into 6 into, that's it. Oh sorry, 10 into 9, wait, 10 into 9 multiplied with 8 multiplied with 7 multiplied with 6 factorial divided by 6 factorial multiplied with 4 factorial. So 6 factorial got cancelled. Now we have 10 into 9 into 8 divided by into 7 divided by 4 into 3 into 2 into 1. 4 2s are 8, 3 3s are 9, 2 2 cancelled. So we have 10 3s are 30, 30 into 7, 210 is our simple answer. I'm just showing you how quickly you can calculate this. Sometimes students fear binomial theorem just because of this only. That there is so much of calculation, which is nothing, right? This quickly you'll be able to calculate, just like you used to calculate fractions and decimals in your previous classes like 9th and 10th. Okay. Now, based on notation itself, many questions do come in your mains also. You can see very simple questions would come in your JEE mains also, just based on your notations, nothing else. Guys, I'll just take a small break. There is this call from my daughter which I have to take. Hi everybody, sorry if you had to wait. I had an urgent call to attend. I could not skip that, otherwise I don't do that in the class. But yeah, so do you know Rakshita Singh ma'am? She's a teacher at an academy. Yes, I'm Johnny, I know. Tell me, you have a message for her? Yes, so this question, 2nC3 divided by the ratio of 2nC3 over nC3 is given to us as 10 over 1. Then the ratio of n square plus 3n to n square minus 3n plus 4 we were supposed to find. So what we'll do, we'll break this, we'll find some n, something related to n. Obviously we'll have, it's better that we find the value of n. What should be the idea? That we find the value of n. That should be the idea, then only we can find this. Where will we get the value of n from? From here only. We'll have to solve this. So how do we solve this? 2nC3 over nC3. So 2nC3 will be what? 2n factorial. 2nC3 will not be 2 into n factorial. It will be 2n complete factorial. Many students get confused in this also. They take 2 common and n factorial. They'll cancel n factorial. For that only this question is being introduced over here. So 2n factorial divided by 2n minus 3 factorial, right? Multiplied with 3 factorial. Divided by n factorial divided by n minus 3 factorial multiplied with 3 factorial. This is how it's going to be. Okay, now 2n factorial upon n minus 3. Now can you cancel this n factorial? You might get the feeling that we should cancel this n factorial and it will all be done. Correct? Here we can cancel this 3 factorial, not a problem. Right? We can cancel this 3 factorial and this is just going to become 2n factorial multiplied with 2n factorial multiplied with n minus 3 factorial divided by n factorial multiplied with, or I should just put brackets, n factorial multiplied with 2n minus 3 whole factorial. This is how it's going to look like. Now try to resolve this, try to summarize. Now 2n factorial you can write as 2n minus 1, 2n minus 2. Right? What will be your 2n factorial? If you look at this carefully, 2n factorial can be cancelled with this only. Now if I check, 2n factorial is what? 2n into 2n minus 1 into 2n minus 2 into 2n minus 3. Correct? So this 2n factorial I am writing 2n multiplied with 2n minus 1 multiplied with 2n minus 2 multiplied with 2n minus 3 and so on. So I can write 2n minus 3 factorial. Correct? Correct. Divided by 2n minus 3. Now actually I should write a bit bigger. So this 2n I am writing 2n into 2n minus 1 into 2n minus 2 into 2n minus 3 factorial. This 2n term is this, right? N minus 3 factorial, I'll let it remain as it is, n minus 3 factorial. Now n factorial, how can I write? N multiplied with n minus 1 multiplied with n minus 2 multiplied with n minus 3 and so on. So n minus 3 and so on is n minus 3 factorial, right? Multiplied with 2n and multiplied with 2n minus 3 factorial, which is here as it is, n minus 3 factorial, n minus 3 factorial gone, 2n minus 3 factorial, 2n minus 3 factorial gone. This is how you are supposed to solve it, and now we just need to cancel this, right? So n and n is getting cancelled. Here what are we getting? 2n minus 1 is there, so 2n, n minus 1 will come out common from here. 2 into 2, 4 it will become, n minus 1 will cancel this. 4 into 2n minus 1 divided by n minus 2. This is given to us is equal to 10. And when we are solving this, we are just getting 2n equal to 16 and n equal to 4. And putting n equal to 4, this will just become 16 plus 12 divided by 16 minus 12 plus 4. So we'll be getting 16 plus n is 8. Sorry, n is 8. N is 8. N will come out to be 8. So this will become 64 plus 24 divided by 64 plus 64 minus 24 plus 4. So 64 to 88. 88 divided by 44, which will just give us 2. So our correct answer comes out to be this. Remember, solving these is a very simple art. 2-3 questions also, if you'll practice like this, know how to cancel the terms in notations. You'll easily, and these are easy questions. This year also some questions came only on in 1 or 2 of the shifts only on notations. Questions have come this year also. Please don't forget to like the session. Okay, if you're there. Now actual binomial expansion, the theorem, right? The expansion of binomial theorem, or the expansion of x plus y to the power n. Achha, we remember simple thing, no? X plus y whole square, right? X plus y whole square is what? X square plus y square plus 2xy. Correct? Now, this only I'm writing in a different way. So, 2c0 x to the power 0 y, sorry, x to the power 2 minus 0, that means 2, y to the power 0, right? Plus 2c1, I'm increasing this, 2c1 x to the power 2 minus 1, that means 1, y to the power this r, that is 1, plus 2c2 x to the power 2 minus 2, that is 0, y to the power 2. This will become what? 2c0 is what? 2c0, just try to think. 2c0, nc0 is always equal to 1. N factorial, 0 factorial. Remember one thing I didn't tell you, 0 factorial is just equal to 1. This you should remember. Right, 0 factorial is 1. So nc0 will be what? N factorial divided by n minus 0 factorial. That means n factorial multiplied with 0 factorial, which is 1. So this will just come out to be 1 only. Right. So nc0 is always 1. nc1 is n. What will be nc1? Just think nc1, n factorial divided by n minus 1 factorial multiplied with 1 factorial. So n factorial multiplied with n minus 1 factorial. N factorial can be written as n into n minus 1 factorial divided by n minus 1 factorial. So this will get cancelled. What will get? N only. Right? N factorial is what? N into n minus 1 factorial. So this will come out to be as n. nc1 is always n, nc0 is always 1. Small things, remember, 0 factorial is 1. You should remember, but when you'll practice, no, you'll realize these things. If you have studied this chapter already, then you know. So this comes out as what? X square, because x square only 2c0 will become 1. Y to the power 0 will become 1, only x square. From here what we'll have? 2c1 will become 2, nc1 is n, x into y, 2xy, plus 2c2, ncn will be also 1. ncn and nc0 are same. ncr is equal to ncn minus r. So this will just become x square plus 2xy plus y square. That means x square plus y square plus 2xy, which we already know. Now pay attention at x plus y whole cube. 3 will start with 0, 3c0, x to the power 3 minus 0, that is 3, y to the power 0, this one as it is, plus 3c1 will increase this r by 1, 3c1, x to the power 3 minus 1, that is 2, y to the power this one, that is 1, plus 3c2, x to the power 3 minus 2, that is 1, y to the power 2, plus 3c3, x to the power 3 minus 3, that is 0, y to the power 3. And we know that x plus y whole cube is nothing but x cube plus 3x square y plus 3xy square plus y cube. Right? X cube plus y cube plus 3 into x plus y. 3ab into a plus b. Right? That is what we have written. Now 3c2 will become what? 3c2 and 3c1 will be same. ncr is equal to ncn minus r. 3c1 we know is equal to 3. So 3c2 will also be equal to 3. So x cube. These things we have already known. Now because these are true, or we can say because these are true, binomial expansion is true, or we can say these all are derived from binomial expansion only. So what we are basically doing, x plus y to the power n, nc0, x to the power n, right? Y to the power 0. That means we don't write it. NC1 x to the power n minus 1 y to the power 1. Then NC2 will keep increasing this r by 1 1. On x the power will be n minus r. On y the power will be r. So we can say general term, any term x plus y to the power n, any term will look like this: NCR x to the power r x to the power n minus r y to the power r. This is going to be the general term. Any term will be of this form. Now this r can go from 0 to n, right? And n can go from n to n will remain same in the coefficients, but r will go from 0 to n, right? N is remaining same only. Over x the power will be n minus r, over y the power will be r, right? This is how you should remember it. And this is oh my god, Sarvan, Sidru, Mami, Adad, Shimon, Joseph, God of Man, oh my god, Ashwin, son of Shimon, Vedhantu, Divya Darshan, lawyer sir. What are you writing? No idea. I got. Okay. No idea, beta. What are you writing? Alright. Okay. So basically general term, or this is just your sum of all these terms. Now this is the this is how you write it. K is increasing from 0 to n and sum of all these terms. This is a general term. This is your Tn. Tn is what? NCK x to the power NCK or r. Instead of r they are using k this time. So you should be familiar with these type of confusions without any problem, right? Without any problem. NCK x to the power n minus k y to the power k. Now this is Tn, and if we find the sum of Tn where k is from 0 to n, k increases from 0 to n, then what we'll get? We'll get binomial expansion only. This notation, this form, you should be able to understand. You should be able to understand this particular type of form, right? That's how it stays easier to remember. Now, how many terms are there? In x plus y whole square, how many terms were there? 3. In x plus y whole cube, how many terms were there? 4. In x plus y to the power n, how many terms will be there? N plus 1. Okay, ji. Sum of powers of x and y in each term is n. You can see n minus 1 plus 0, n minus 1 plus 1, n, n plus 0, n, n minus 2 plus 2, n, n minus 1 plus 1, n. In all the terms, the sum of the powers of x and y will always remain n. These are small things, but questions can be developed by these without even letting you know that this is very easy. They'll make the question look very difficult, and it will just be on these simple properties. Coefficients of term equidistant, very important thing. Coefficients of the terms equidistant from end starting are equal. Why? Because we know NCR is equal to NCn minus r. That means NC4 will be 8C4 will be equal to, if we talk about x plus y to the power 8, if I'm simply talking about x plus y to the power 8. Now coefficient of equidistant terms will be same. Let's see what will be the coefficients. So first will be 8C0 x to the power 8 y to the power 0 plus 8C1 x to the power 7 y to the power 1 plus 8C2 x to the power 6 plus y to the power x to the power 6 plus y to the power 2 plus I'll take a little more space, 8C3 x to the power 5 y to the power 3 plus 8C4 x to the power 4 plus y to the power 4 into y to the power 4, 8C5 x to the power 3 y to the power 5 plus 8C6 x to the power 2 y to the power 6 plus 8C7 x to the power 1 plus y to the power 7 plus 8C8 x to the power 0, or we should not write any x, that will also work. Did we not write? Here we have not written. So here I'll remove y. Right here I'll remove y simply. Right here x to the power 0, so I'm not writing x, only y to the power 8. Now it's saying coefficients of terms equidistant from beginning and end are same. First term and last term coefficient, look, 8c0 and 8c8, are they same? 8c0 and 8c8 are same. NCR is equal to NCN minus R, n minus R, 8 minus 8 is also 0. Now 8c1 and 8c7, aren't they same? They are same. 8c7 will be equal to 8c1. Why? Because NCR is equal to NCN minus R. 8c1 is equal to 8c8 minus 7. That means 1 only, right? Or 8c1 is equal to 8c8 minus 1, which is 8c7. That's how it should be. 8c2 will be equal to 8c6. Yes. 8c2, you can calculate also if you want, right? Be perfectly satisfied. 8c2 will be equal to 8c6. 8c3 will be equal to 8c5. Arey bhai, 8c3 will be equal to 8c8 minus 3 na. NCR is equal to NCN minus R. That's why coefficient of terms equidistant from beginning and end will always be same because of this particular property. Remember it. Very applicable, many times it will be directly used. Now try to write these on your own once, right? Take your time right now, only try to write these on your own. You'll actually, the thing is about understanding the pattern. So when you'll write now, the pattern of writing this will get stuck in your mind. For example, slowly if you write 4c0 x to the power 4 y to the power 0 plus 4c1 x to the power 3 y to the power 1 plus 4c2 x to the power 2 y to the power 2 plus 4c3 x to the power 1 y to the power 3 plus 4c4 x to the power 0 y to the power 4. This quickly you should be able to write it. So here y to the power 0 you don't have to write. 4c0 will become 4 only. 4c0 will become 1. Okay, so this will be x to the power 4 plus 4x cube y plus 4c2 x square y square 4c3 xy cube. This quickly you should be able to write. Now minus y has come. So in minus, just write the same expansion, but alternatively keep on moving with plus and minus, nothing else. Same expansion. That means 4c0 x4 y0 minus, plus here, so minus here. 4c1 x cube y plus 4c2 x square y square plus 4c3 x, sorry, minus will come here, minus 4c3 x y cube plus 4c4 x y to the power 4. Why? Because power, negative power, sorry, negative is y, and whenever it will get an odd power, we'll get a negative sign. Odd power means every alternative term it will get an odd power, and that's why we are getting a negative sign. Minus y to the power 1 will be minus y. Minus y to the power 2 will be plus. Minus y to the power 3 again will be minus. So that's why, right? This expansion simply 5. So let's write a bit better way. 5c0, that means 1, x to the power 5, y to the power 0. So can I write simply x to the power 5? Right, it's better to write x to the power 5. 5c0 will be 1 only. Then 5c1, right? So, okay, let's write 5c0 over here so that you can understand. The 5c1, x to the power 5 minus 1, that means 4, y to the power 1. 5c2, x to the power 3 y to the power 2 plus 5c3 x to the power 2 y to the power 3 plus 5c4 x to the power 1 y to the power 4 plus 5c5 x to the power 0 y to the power 5. This quickly you must be able to write these expansions, then only your confidence over binomial theorem will increase and you'll be easily able to attempt the questions, right? Same thing will happen here, just minus, plus, minus, plus, minus, plus, minus. Wherever y has a odd power, that's there we'll have a minus. That's it. Okay. Now in case of 3 terms, just club 2 terms. Any 2 terms you can club. Right, 1 plus x you can club. Generally try that without power term. you can club, and this term you can leave it as it is. So this will just become 3c0, right? 3c0, 1 plus x to the power 3, x square to the power 0. Next term will be 3c1, 1 plus x to the power 2, x square to the power 1. X square is one term now, 1 plus x is another term now, right? Two types of terms here we are getting, and this is how it's going. Now also try to observe these type of things. X plus y to the power 4 plus x minus y to the power 4, when we will do, what will happen? Just try to do it once on your own. I'll show you what will happen. So x 4c0, x to the power 4, y to the power 0 will come, right? Plus 4c 1, x to the power 3, y to the power 1 will come, plus 4c2, x to the power 2, y to the power 2 will come, then 4c3, x to the power 1, y to the power 3 will come, then 4c4, x to the power 0, y to the power, here y to the power 0, so y to the power 4 will come. Now when we'll add this x minus y to the power 4, what will happen? This term will remain same, 4c0, x to the power 4, y to the power 0, right? This will get subtracted, this will become minus because y has a negative power, 4c1 x cube, y to the power 1. This will remain plus 4c2 x square y square. This will be negative 4c3 xy cube. This will remain positive 4c4 x square, x to the power 0, y to the power 4. So all the odd powers are going to get cancelled and even powers will get doubled. So result will be 2 times of all the even powers, 4c0, 4c2, 4c4. Okay, when we add like this, only even powers will be doubled. All the odd powers of y will get cancelled and become 0. Same thing is going to happen here. 4c0, 4c2, 4c4 remained and doubled, right? All negatives got cancelled. In this case also 6c0, 6c2, 6c4, 6c6 will remain. All the negatives will get cancelled and this will be doubled. So these should be on your tips so that you are not expanding the entire thing in the exam. If something related to this comes, you should be easily able to mark it right away. For example, try to do this question. Right? It is you don't have to open in anything. You just double all the even terms. That means 5c1. All the even terms, try to solve it. But pay attention, we are subtracting now. We were adding here, we are subtracting here. Okay, pay attention. Don't directly jump on the conclusion. Pay attention, we are subtracting here. When we were adding, what was happening? All the even powers were getting doubled. Even powers of y, all the terms with even powers of y were getting doubled, right? This is what it was happening. All the even powers of y, 0 is also we are considering even, were getting doubled. All the odd powers of y were getting cancelled and becoming 0. But when we'll subtract, what will happen? All the odd powers will get doubled because minus minus will become plus, and all the even powers will be cancelled. So what will happen over here? All the odd powers will get doubled. 5c1, 5c3 and 5c5 will be doubled. So 2 times of 5c1, this term only will write. 5c1 will become 3 to the power 4 root 5 to the power 1 plus 5c3, because 5c2 will get cancelled. Try to open it on your own, you'll be able to understand better. 3 to the power 2 root 5 whole cube, right? Plus 5c5 3 to the power 0 root 5 to the power 5. This will be our final answer. Okay. This we can calculate very easily. So just calculate this. 5c1 is 5 only. 5c1 here also you'll have to just root 5 to the power 3 will become 5 root 5. So that you can club over here. Simple calculation, and finally we are getting the answer as 1760 root 5. The point was, when we are subtracting, odd powers will remain and get doubled. When we are adding, even powers will remain and get doubled. Very important thing. Easy, applicable, but actually very important thing. Now about general term. Very important. Many problems came. Very important. And you can also say trending. You can say trending. Why am I saying this is trending? Because in 2025 JEE attempt, we have seen a lot of problems from the general term of binomial expansion. So that's why I'm saying this is something which is actually important, and this is something which is very much expected in your second attempt, which is going to be in April. So practice this general term, as I told you just now only. I told you, right? What will be the general term? I told you, right? Tn is equal to what? NCR x to the power n minus r y to the power r. This should be the general term. What else can we teach in general term? But with this, actually calculations and understanding of the question becomes a little bit complex. So that's why we say general term we write like this. Now try to understand. In x plus y to the power n, NCR x to the power n minus r y to the power r is understandably in my mind, in your mind, that's your general term. That's how any term will look like. But suppose if we are finding seventh term of binomial, suppose I want to find T7. So what will be T7? Will it be NC7 x to the power n minus 7 y to the power 7? No, it won't be, right? Because you see NC0, right? NC0 is the first term, NC1 is the second term, NC3 is the third term. So seventh term will have NC6, correct? Getting my point? Right? Why we should remember it like this? Because this way it will be easily applied. Otherwise, you'll do the silly mistake of putting R as 0, 1, 2, 3, 4 only. Like in T7, it will not be NC7. The coefficient will not be NC7. The coefficient will be NC6. Because in first term, the coefficient is NC0. In second term, coefficient is NC1. In third term, coefficient is NC2. And just a minute. So pay attention at this. I'll just be there. Did you understand what I'm trying to say? So this is how you should remember it. Tk plus 1, will remember it with Tk plus 1. So T7 if I'm finding, it will be T7 means Tk plus 1. T7 will be 1 less. Here R will be 1 less than this. So NC6 x to the power n minus 6 y to the power 6. Suppose in the expansion of x plus y to the power 24, I am trying to find the 8th term in this. If I want to find 8th term in this, T8 will be what? Tk plus 1 is equal to NCk x to the power n minus k y to the power k. So Tk plus 1, this is k plus 1. So here coefficient will become NC7 x to the power, so that means 24C7 will be the coefficient, right? X to the power 24 minus 7, so 17, y to the power 7. Okay, so that will be your 8th term in this expansion. This is how you should remember this, and if you remember it like this, I don't think any question will trouble you. Now let's see what all type of questions they can ask in this particular scenario. If the 21st and 22nd term of the expansion 1 minus x to the power 44 are equal, they'll try to make you compare the terms. This is very common type of questions in JEE, right? Especially in mains, very common type of question. So now this 21st and 22nd term in the expansion of this are equal. Now 21st and 22nd term in one expansion are equal. Which terms are equal? Do we know the property? Right, we know the property, right? Equidistant terms are equal generally. equidistant terms are equal. So obviously if there are 44 is the power, 45 terms will be there. 45 terms will be there, correct? 45 terms are going to be there, and in that 24th and 22nd terms are equal. Terms are equal, not the expansion, not the coefficients are equal. Try to understand this, don't get confused. You must be thinking, sir, 45 terms will be there, 45 terms will be, which means that, sir, 23 and 24, 23 will be the middle one, right? 23 will be the middle one. So 22 and 24 should be same, but coefficient of 22 and 24 will be same. Terms are not equal, right? In this they are saying terms itself are equal. So that means T21 and T22 are equal. As simple as that. Now what will be T21? 44C22 minus x to the power 21. This will simply be 44C21 multiplied with minus x to the power 21, right? T21, or sorry, T22. This will be my T22. 44C21 into minus x to the power 21, because 1 to the power 44 minus 21, 1 to the power anything, doesn't matter, minus x to the power 21. This will be equal to T21. T21 will be what? 44C20 into minus x to the power 20. Isn't that? So this can be easily solved. 44C21 divided by 44C20. There will be 44C21 divided by 44C20, which will be equal to minus x to the power 20 divided by minus x to the power 21. That means minus x to the power minus 1, which will be minus 1 upon x. So here we can solve for x very easily. These two. Now here, don't make the mistake of solving this. N is same, R is being decreased by 1. Right, so n minus r plus 1 upon r. That means 44 minus 21 plus 1 upon 21. Simply, this is how we are going to solve it. So this will become 24 divided by 21. This will be 24 divided by 21 equal to minus 1 upon x. And x only we had to find. So x will become just 24, 21, 7, 3, 7, 3 7s. And 3 8s. So 8 was minus 7 upon 8. Your x will just become minus 7 upon 8. So one notification which is coming on your screens right now, if you are watching it later also, on your screen there is one notification. I want to tell you one important thing. The thing is that on our Nexus channel, if you go on Nexus channel, I'll show you. If you go on Nexus channel, some surprising things are going to come. JEE Nexus channel. Just search for JEE Nexus by Unacademy. Right, this channel. If you go at, right here, you can see in the notifications there are amazing things which are going to happen. There are many good surprises which are going to be there for all the JEE aspirants. Right, all the JEE aspirants. So the only thing which you need to do is just subscribe if you haven't till now, and if you are already subscribed, just click on the notify me button. So you can see many good events are going to be there, many good surprises are going to be there for all of you. Many good things are going to come up for all of you. You can see these things. Notifications will come. 1st March is going to be the RM event. If you are hearing about this, on RM event itself, many good and surprises will be revealed for all 2025, 2026 and 2027 aspirants. So go on this channel, click on the notify me button. The links are also there. The link is there in the chat box. Link will be there in the description. Check what is it, what all surprises are going to be there, and attend the event on 1st of March, which is going to be a very fruitful event for all of you. Okay, let's come back to what we were doing. So this is about the general term. On basis of this, many questions do come in mains as well as advanced, and very easy questions. You just need to understand how, if the third term of the binomial expansion of this is equal to this. Now simple calculation, right? Third term, that means T3, which will be NC2, coefficient will be NC2, correct? So in this, if we write 1 plus x to the power log of x base 2 to the whole power 5. If here I'm finding T3, if here I'm finding third term, what will it be? NC2, that means 5C2, 1 to the power 5 minus 2, that means 3, 1 to the power anything, does not matter, we don't need to write, x to the power log of x base 2 to the power of 2. This is given to you as 2560. Now it's just about calculation and nothing else, and using log over here. Right, so 5C2 if we solve, 5C2 if we solve, it will be 5C2 and 5C3 will be same, right? So 5 factorial upon 2 factorial multiplied with 3 factorial, that means 5 into 4 divided by 2, so 10. I think 10 we are getting. So this will become simply x to the power of log x base 2 whole square. 10 will go here and it will become 256. So your x to the whole power log of x base 2 will be equal to plus or minus 16. Correct? But here we'll not take minus 16 because it's an exponential function and we only talk about positive exponential functions. So your log of x base 2, x to the power log of x base 2 will become equal to 16. Right, so minus 16 will reject, your x to the power log of x base 2 will be taken equal to 16. Okay, now you can simply take log both the sides. So you'll have log of x base 2, log of x base 2 and log of 16 base 2. Right, if you take log both the sides with base 2, you'll simply have this will come in front. So log of x base 2, right, I'm just taking log over this. So log of x to the power of log of x base 2. Power comes in the multiplication in the front and this will remain as it is, log of x base 2. I am taking log with base 2 and here also log of 16 base 2, which will be 4. So your log of x base 2 to the power 2 is equal to 4. So your log of x base 2 is equal to 2. So x will be equal to 4 or 1 by 4, because here though we can take no log x base 2 can be plus minus 2. This is log function, not exponential, right? This is log function. So here we'll have plus or minus 2. So x can also be equal to 2 to the power minus 2, that means 1 by 4. Both values will be correct. 1 by 4 and 4, both the values of x will be correct. Here what it was exponential function, that's why we rejected the negative value. There it's a log function, we'll have to accept. Okay, so one of the options. All right, one more question. Find the fourth term from the end in the expansion of this. These type of questions are also generally seen in JEE. So you should just know that kth term from the end in the expansion of x plus y to the power n is equal to n minus k plus 2th term from the beginning. This is just same. Equidistant term from beginning and end are same. But how to find equidistant term? If you are finding kth term from the end, suppose for example over here we are finding 4th term from the end. So k means 4. It will just be equal to n minus k plus 2th term from the beginning. That means 9 minus 4 plus 2. So 9 minus 2, that means 7th term from the beginning will be equal to 4th term from the end. Why? Because n plus 1 terms are there, na? N plus 1 terms are there, right? If we have n terms, and 4th and rth term from the starting will be equal to n minus r plus 1. But here we have n plus 1 terms. So that's why n minus k plus 2th term. Remember this very easy. Kth term from the beginning is equal, kth term from the end is equal to n minus k plus 2th term from the beginning, and vice versa is also true. Kth term from the beginning will be equal to n minus k plus 2th term from the end. Both are same thing only. So 4th term from the end will be equal to 9 minus 4 plus 2th term from start or beginning. Right, so that will become n minus 2, that means 9 minus 2, that means 7th term. So 7th term we have to find. 7th term will be equal to 9c6, right? Seventh term coefficient will be 9c6 x cube by 2 to the power of 3 and minus 2 by x square to the power of 6. This will be the term. Okay. So I think terms will get cancelled over here, right? That's why I think we can do some calculation. So x square to the power 3 and here we have x square to the power 6. Sorry, x cube to the power 3. So it will become x to the power 9, right? So here what we will have 9c6, so we can solve separately. 9 factorial upon 6 factorial into 3 factorial. So that will just become 9, 8 and 7 divided by 3 into 2. That means 2 4s, 3 3s, 12, 12 7s. 84 I think, right? So this will just become 84 over here, right? This will have 84 or 64. Just check once. 7 4s are 20, 12 and 7, 84 only, right? So this will just become 84 multiplied with x to the power 9 divided by x to the power 12. Right, 12 will come, no? 9 minus 12, x to the power 9 divided by x to the power 12 will come. So we'll have x to the power minus 3 divided by minus 2 to the power 6, that means 2 to the power 6 and 2 to the power 3. So 2 to the power 3 will remain, right? 2 to the power 3 will remain. So here we are going to have 84 divided 2 to the power 3, that means 8. 84 divided by 8. Wait, 84 into x to the power 9. What am I doing here? X to the power 9 divided by x to the power 12, x to the power minus 3, correct. 2 to the power 6 divided by 2 to the power 3, 2 to the power 3 is also correct, into 2 to the power 3 over here. Correct only. No. 84 into 8, that means 672. This will become 672 and divided by x cube. Let's check the answer. So yeah, correct. This easily you can calculate these type of things. Just remember the small important properties. What are they saying? Fourth term from the beginning, fourth term from the end is equal to fourth term from the beginning. Yeah, this is also one way. Fourth term from the end will be equal to fourth term from the beginning. That also is a way of saying it. Fourth term from the beginning, na? What did we do? We said that fourth term from the end will be 9 minus 4 plus 2th term from the beginning, right? So that is okay. Alternate way, what are they saying? Seventh term from the beginning. Fourth term from the end will be seventh term from the beginning, and here they are saying fourth term from the end will be equal to fourth term from the beginning. Coefficient of fourth term from the end will be equal to coefficient of fourth term from the beginning, na? Why are they saying like this? Acha, coefficient only they have compared. Okay, anyway. Chaliye. Let's analyze middle. Acha, 9 terms are there. That's why they are saying. So 10. So 10 in 10 terms. Yes, 5th and 6th term will be same. So 4th term from the starting will be equal to 4th term from the end. That's why they are saying, because 10 terms are going to be there. So 4th term from the starting and 4th term from the end will be equidistant. That is the alternate solution which they are talking about. Now next thing is middle term in the expansion. This is also very important. Middle term, how will you analyze? Now middle term, very easy. In x plus y to the power 6, how many terms are going to be there? You know, x plus y to the power n has n plus 1 terms. So this will have 7 terms. In 7 terms, middle term will be 4th term. Right? This we know, right? If odd number of terms are there, so middle term is n plus 1 by 2. That means 7 plus 1 by 2. 4th term will be middle. 3 terms here, 3 terms here. Right? 3 terms on the left, 3 terms on the right. So if we have power is even, that means we are going to have odd number of terms. In odd number of terms, there will be only one middle term. So in this one, what will be the middle term? In this one, 7 terms are there. So 7 terms are there. That means 4th will be the middle term. Right? 7 terms are there. In 7 terms, 7 plus 1 by 2 is going to be the middle term. That means 4th will be middle. So 4th term we know T4, how can we find? T4 is 6C3. Tk plus 1 is NCK. x to the power 6 minus 3, that means 3, y to the power 3. So 63, x to the power 3, y to the power 3 will be your middle term in this expansion, right? X to, where is y to the power 3? Achha, they are asking out 1 plus x to the power 6. Kya? Arey, this question changed. Okay, they have solved for 1 plus x to the power 6. We solved for, so if x is 1, if x is 1, it will only be 1. If y is 1, then there will be no y here, x to the power 3 only will come. 63 is 20 for you. Now 13 terms are there. 13 is the power. In the second case, 13 is the power. So total terms will be 13 plus 1, that means 14. 14 terms will be there, even number of terms. So 14 by 2 and 14 by 2 plus 1, both will be the middle terms. There will be 2 middle terms, right? Middle term, if there are 14 terms, then 14 by 2 and 14 by 2 plus 1, both will be middle terms. That means 7th term and your 8th term will be the middle term. 7th and 8th both will be the middle term. In even number of terms, there is no one middle, there are 2 middles now, right? So 7th and 8th, just divide by 2 and add 1. That's it. 7th and 8th term will be the middle terms. So in case of odd, n plus 1 by 2th term and n plus 1 by 2 plus 1, 1th term. No, this is wrong. This is wrong. This is wrong. Achha, n is 13. That's why they are saying. Kya? Haan, theek hai. In that case, we know n plus 1 terms will be there. So you can think anyways. 13 is the power. So 14 terms will be there. In 14 terms, 7th term and 8th term will be the middle term. 14 by 2 and 14 by 2 plus 1 will be the middle term. So 7th term will be T7. That means 13C6, 1 to the power 13 minus 6, x to the power 6. 13C6, x to the power 6. T8 will be T7 plus 1. Right? Tk plus 1. This is just applying the formula. T8 will be 13C8, 1 to the power 13 minus 7, x to the power 7. That's how you can simply realize this. So in the summary, we can simply say middle term of 1 plus x to the power n is n if n is even. If this n is even, if we have 14, if this n is 14, then number of terms will be 15. If n is even, then number of terms will be odd, and in that case, the middle term will be n plus 1 by 2. This is wrong. This is wrong. N plus 1 by 2th term when n is even. When n is even, number of terms will be odd and middle term will be n plus 1 by 2th, not n by 2 plus 1. N plus 1 by 2th term. If n is odd, suppose it is 13, so number of terms will be 14. Number of terms even, that means there will be 2 middle terms. That means n plus 1 by 2 plus n plus 1 by n plus 3 by wait, n plus 1 terms. Achha, this formula is correct only, no? If n is even, this way also we can find, right? This way also we can find. It's saying if n is even, right? So if n is let's say 14, so middle term will be 14 by 2 plus 1, which is correct, right? Because 14 by 2 plus 1 is what? 7 plus 1, 8. Suppose if we do like this, it is 14, number of terms will be 15. Odd number of terms, so middle term will be 15 plus 1 by 2. So you do n plus 2 by 2 or you do n by 2 plus 1, same thing only. This is n plus 2 by 2 or n by 2 plus 1, same thing only. We are doing n plus 2 by 2 and here they have written n by 2 plus 1. So same thing only. This is also 8th. This is also 8th. This is also 8th now over here. So 8th term is going to be our middle term. And in case when n is odd, suppose it is 13. So number of terms will be 14. That means number of terms will be even. That means there are going to be 2 middle terms. That will be n plus 1 by 2th and n plus 3 by 2th, right? N plus 3 by 2th. Why? Because it is, suppose if n is suppose if your n is 13, so number of terms will be 14. Middle term will be what? 14 by 2 and 14 by 2 plus 1. So you should remember, I remember like this. You can remember anyhow. Middle term, finding the middle thing is should not be a trouble for you. If there are 14 terms, so 14 by 2, that means 7th and 8th will be your middle terms. If n is suppose 21, if n is 21, number of terms will be 22. In 22 terms, middle terms will be which ones? 11th and 12th. N by 2 and n by 2 plus 1. Simply. That way also it will work. If the middle term in the expansion of this question is from 2021, you can see if the middle term in the expansion of this is equal to 7 by 8, then x is equal to what? Middle term in the expansion. What is the power? Power is 10. Power is 10. Number of terms will be 11. Number of terms are odd. That means middle term will be 11 plus 2, 11 plus 1 divided by 2. But number of terms will be 11. Simply think like that. No, number of terms will be 11. In 11 terms, which will be the middle term? Sixth term will be the middle term. 11 plus 1 by 2. 11 plus 1 by 2. That means 12 by 2. That means sixth term will be middle. I'll write completely for 10 terms. There will be 11 terms. And middle will be 11 plus 1 by 2. That means sixth term will be middle. So we are going to find T6. T6 will be what? 10C5. 1 by x to the power 5 multiplied with x sin x to the power of 5, which is given to us as 56 plus 7. So 63 by 8. Okay, ji. Check this out quickly. Right. So now 10C5 is just going to give us how much? Acha, 1 by x to the power 5 and x to the power 5 will directly get cancelled. 10C5 we can calculate 10 into 7 into 6 into 5. Right, not 5. 10 into 9 into 8 into 7. What am I doing? 10 into 9 into 8 into 7 into 6 divided by, multiplied with 5 factorial, and 5 factorial got cancelled. 10 minus 5 is also 5. So 5 into 4 into 3 into 2. Okay. So this we are going to solve. 3 2's, 2 2 cancelled, 4 2's. Okay. 5 2's. Okay. So we have 4 into 63. 63 into 4. 256. So 252. This will be just 252. So this will become 252 multiplied with 1 to the power 5, x to the power 5, x to the power 5 got cancelled. Sine x to the power 5 only we are going to have 63 by 8. So we just need to solve for sine x. That's it. Sine x will come how much? 63. So it'll go in 9. Both are going. 9 7s are 63 and 9 28 is this. So 28 into 8 we are going to have sine to the power 5x will just come as, sine to the power 5x will just come as 1 over 32. Okay, and now you can solve, I think, right? So 1 by 2, right? So x to the so sine to the power 5x, sine x is equal to 1 by 2. Your sine x is equal to 1 by 2. So principal domain, in under principal, all the principal values it can take. X will be equal to nothing but n pi plus minus 1 into minus 1 to the power n pi by 6. This is going to be the answer. In trigonometry you must have learned this. Okay, let's go ahead. So these type of questions you can easily solve. Just be very well practiced. Practice these questions only. That also will give you a lot of confidence and will help you solve questions in the exam. Now general term of the some special cases we should remember. When we have 1 plus x or 1 minus x, the expansion becomes very simple. Note down the expansion over here or just try to do this expansion on your own once. It will be very much easier. 1 plus x to the power n, nc0 plus nc1 x plus nc2 x square, like this only it will go, right? nc0 x to the power 0, x to the power 1, x to the power 2, x to the power 3. Same thing, if we have a minus, then nc0 minus nc1 x, nc2 plus x, nc2 x square minus nc3 x cube plus nc4 x to the power 4, and it will keep going on like this. Minus 1 to the power n will be multiplied. Minus 1 to the power 0, 1 only, minus 1 to the power 1, negative, minus 1 to the power 2, positive, minus 1 to the power 3, negative. So remember these expansions, write them down once on your own, because many times, you know, students will not be practiced with this and they'll start expanding with the general binomial expansion. So that's not recommended. You should not do it. right? It's all about calculation in binomial theorem, right? It's all going to be about calculation and the speed of calculation, accuracy of calculation, nothing else. The theorem is one only. Applications of that theorem only are going to be taught, and the questions are going to be asked on the basis of that only. Now in the expansion of coefficient of x is 3, now we are moving towards next type of problems, which are coefficient related problems. Coefficient of expansion, coefficient of a term in the binomial expansion. So those type of questions are also very popular, hot and trending right now in 2025. First session also we have seen a lot of questions. So try to attempt this question. If in the expansion of 1 plus x to the power of m multiplied with 1 minus x to the power of n, the coefficient of x is 3. The coefficient of x is 3. That means coefficient of x to the power 1 is 3. Coefficient of x to the power 1 is 3, because here what is the variable? X only is the variable, right? Coefficient of x to the power 1 is 3. So if we expand, if we look at the expansion also, no, try to expand this. Just give me a minute. Try to expand this. I'll be back in a minute. Try to expand this once on your own. If in the expansion of 1 plus x to the power m, 1 minus x to the power n, the coefficient of x, that means coefficient of x to the power 1 is 3. Try to expand in your mind. I'm just asking you, try to solve this with whatever you know. Now see, if we expand 1 plus x to the power m, right? If we simply expand 1 plus x to the power n, it will be 1 plus, so first part 1 plus nc0, right? mc0 will become 1. So I'm writing 1 only. mc0, 1 to the power m, x to the power 0. Correct? So first term will be 1 only. 1c0, which is 1, into 1 to the power 0 into into x, 1 to the power m into x to the power 0. 1 to the power m will be 1 only. X to the power 0 also will be 1. So entire term will be 1. And moreover, I just showed you this, right? I just showed you this. 1 plus x to the power m, which will be equal to nc0, which is 1 only. 1 plus nc1x plus nc2x square. So 1 plus mc1x plus mc2x square plus mc3x cube. It will keep going on like this. Correct? Till where will it go? MCM x to the power MCM x to the power m. It will go till MCM x to the power m. It will go till MCM x to the power m only. Right? This is the one part. Multiplied to this, we here only, let's write 1 minus NC1 x to the power NC1x plus NC2x square plus NC3 x cube, and it will go till NCN x to the power n. It will keep going on till here. Right? Minus 1 to the power n will be multiplied over here, obviously, if n is even or odd, to make sure of that. So here it will be a minus. Wait, this will be a minus. This will be a minus. Now see, coefficient of x to the power 1 will, how will that be created? Right? If we multiply these terms, 1 will get multiplied to this, 1 will get multiplied to this, 1 will get multiplied to all of these. Then x, how will x to the power 1 will be created? MC1 into x multiplied with 1 and NC1 into x multiplied with 1 will create x to the power 1. Agreed? Correct? MC1 multiplied with 1 and NC1 minus NC1 multiplied with 1 will create x to the power 1. Rest every term will create a greater power of x. If you take MC1 into NC1 into x, x square will be created. Try to think like that. X square will be created, correct? So how will only x be created? MC1 into x multiplied with minus of NC1 into x. This will create power of x to the power 1. Correct? This not this. MC1 into x multiplied with 1 plus NC1 into x minus NC1 into x multiplied with 1. This will create. So basically x will be common and MC1 minus NC1 will be in the bracket. This will have x to the power of 1. Correct? X to the power 1 coefficient is given to us as equal to 3. This will be the coefficient. That means MC1 minus NC1 will be equal to 3. So your MC1 is M, NC1 is N. So M minus N will be equal to 3 and your option A will be very correct. This is how you'll have to actually, in your mind, you'll have to see how will x be created. You see, x square multiplied with anything will create a greater power of x. X to the power 1 you have to create. If you take this and multiply with any of the terms except 1, you'll get a greater power of x. Only multiplying it with 1 will give us x to the power 1. So you'll have to look yourself very carefully how we are going to create x to the power 1 in the expansion, and these small expansion you have to remember. You have to be very well practiced in these. Then only you'll be able to solve. Now next thing is, sometimes identities are given to you. These type of things are given in the exam. Identity, simple identity will be given to you in the exam. This question also I told you that was expected in your JEE Main's first attempt. The question didn't come exactly based on identity like this, but it was based on identity. One of the question was based on identity. So in identity, just remember, identity is not, this is not expansion, this is identity. X plus y whole square is equal to x square plus y square plus 2xy is an expansion also, but it's also an identity. You put any value of x and y, it will be satisfied. So when something in the question is given to you like this, equal to, right, both sides of equal to you have, you are not supposed to expand, you are not supposed to find the coefficient, you are not supposed to find the coefficient of x to the power something. Simple identity is given to you like this, and then coefficient sum, something related to coefficients is asked from you. Something related to coefficients is asked from you. In that case, you have to put value of x as 1 and minus. Now this is true for any value of x because this is given in the question. This will take as identity. This is true for any value of x. So you can put any value of x. Suppose in the first one, suppose we go for the first one. Here if we put x equal to 1 on both the sides, put x equal to 1 on the both sides. So 1 minus 2 into x square, that means 2 into 1 square, that means minus 2, plus 1, that means 1 to the power 6. This side we'll have, right, a0 plus a1 plus a2, because a1 into 1, a1 into 1 square, a2 only, plus a3 till a12 we will have. This sum of all these coefficients will be equal to nothing but 1 minus 2, which is minus 1 plus 1 0. So a1 plus a0 plus a1 plus a2 plus a3 till a12 is just coming equal to 0, nothing else. This simply you can actually solve it. This easily you can actually solve it just by, when identity is given to you. This is an identity, not an expansion. When identity is given to you, you are supposed to solve like this. Put value of x as 1 or minus 1. Most of the cases 1 or minus 1 only will help, and you'll get what you need. You'll have to think, how can we create this? By putting value of x. This is the most efficient shortcut for doing these kind of problems. Now they are asking a0 plus a2, for example, they are asking a0 plus a2 plus a4 till a12, all the even coefficients, suppose. All the even coefficients, suppose. Now how will you create this? You don't need a1, a2, a3, a4. Right? You already know that if we are putting x equal to 1 here, we are getting a0 plus a1 a plus a2 till a12 equal to 0. Now you don't need a1, a3, a5, these type of terms. So you have to cancel that. So how can you do that? Put x equal to minus 1. When we put x equal to minus 1, what are we getting? 1 minus 2 into minus 1 square plus minus 1 to the power of 6. Over here, what will you get? A0. X is -1 now. Minus A1 plus A2 into -1 square. So plus A2 minus A3 plus A4 minus A5. Right? Minus A11 plus A12 till A12 you'll get 12 is even. So with all the even terms we are going to have a plus. Right? This is what it's going to be. What are we getting over here? 1 minus 2 minus 1 minus 1 minus 1. So minus 2 to the power of 6 we are getting, which is this A0 minus A1 plus A2 till A12. Minus 2 to the power 6, 32 into 64. 64 we are getting. This is coming out to be equal to 64. Now what do we already have? We already know that A0 plus A1 plus A2 plus A3 till A12 is equal to 0. And we know A0 minus A1 plus A2 minus A3 till A12 is equal to 64. What can we do to find A0 plus A2 plus A4 till A12? Because all these terms will get cancelled. We'll add both of them. So we simply can say A0 plus A2. A0 plus A2 plus A4 plus A6 till A12. Double of this. Double of these. All these will get double. These will get cancelled. And these will get double. Will be equal to 64. So simply we can say A0 plus A2 plus A4 till A12 is nothing but 32, which is 64 divided by 2. This is how you are supposed to solve these type of identity based problems. Remember that. Okay, solve as many questions as you can. Now, divisibility, very important and most asked in your JEE, in NDA or JEE, whatever it is. In both of these exams, sir, is this enough for bit set? Yes, for bit set this is going to be more than enough. Study with me. This is going to be more than enough. The part which we studied till now, that in fact is enough for bit set, right? Because in your NCERT, remainder theorem, divisibility type of problems also you can study. Those are also there. So BitSat follows strictly the NCERT syllabus and type of problems they ask. Practice these and you'll be through BitSat for sure. Divisibility problems, right? One important point before starting this: 1 plus x to the power n minus 1 minus xn minus nx is always divisible by x square. In the question, I'll show you how, but note it down somewhere. If you see this form, 1 plus x to the power n minus 1 minus nx, 1 plus x to the power 1 plus x to the power n minus 1 minus nx is always divisible by x square. Why also we can see? Why? Because see, 1 plus x to the power n will be what? 1 plus, first term will be 1, then nc1, which will be n into 1 to the power n into x to the power of 1, right? Right. What will be the first term of this? Let me write nc0, 1 to the power n, x to the power 0, plus nc1, 1 to the power of n minus 1, x to the power of 1, plus, and then the terms will go on like this. What will this become? This will be 1. What will this become? This will become just nx, right? 1 to the power anything is 1, nc1 is n, x is x to the power 1 is x. 1 plus nx plus, now nc2, 1 to the power of n minus 2, or let's not write this only 1 to the power anything, and here we'll have x square. We know the expansion also, 1 plus nx plus nc2 into 1 plus nc1 into x, 1 then plus nc2 into x square plus nc3 into x cube. So now we are just going to write like this: nc3 into x cube plus nc4 into x to the power 4, and it will keep going on like this till ncn x to the power n. Correct? Now, if we observe in this part, if you observe first part, 1 plus nx is okay. From all these terms, can I take x square common? Right? So we'll have nc2 plus nc3 into x plus nc4 into x square, and it will keep going on like this. From all these terms I can take x square common, right? What will become the last term? What will become the last term? NCn into x to the power n minus 2. Correct? From all these I can take x square common. So if from this part, if I'm just subtracting 1 and nx, from this if I'm subtracting 1 also and nx also, from the expansion of this, what happened? From the expansion of this, if I'm subtracting 1 and nx also, so this gets cancelled and this entire thing is divisible by x square. You can see this entire thing is divisible by x square. That's why it is written as a property. It's better that you remember. When will you complete whole syllabus, sir? But a whole syllabus before your bit chat, I think. Many of the chapters are already there. Try to read that. 12th class chapters also, some are remaining, which I'll take as soon as possible. Constantly we are taking chapters, right? So, but for bit chat I'm saying, right, from Cengage, some problems, easy to moderate problems of mains you should solve, and NCERT complete solving, even the exemplar book also if you can solve, na, so that will be of great help. Although most of the chapters are there on the channel, well taught. With the help of that also you'll be able to solve the questions. If you need any chapter which is not very clear, I can take that first, put it in the comment boxes. Okay, all right, no problem. Right, so 1 plus x to the power n minus 1 minus x is minus nx is always going to be divisible by x square. For any integer a and b, we say b is divisible by a if b is equal to ak. For, yeah, this we know, this is simple Euclid's lemma, right? Division lemma, right? A is equal to bq plus r. If r is 0 and a is equal to bq, that means a is divisible by b. Okay, now let's see some questions for that. Suppose if you want to do 6 to the power 2n minus 35n minus 1 is divisible by 35 square, yes or no? Suppose it's not proved that, suppose we have to check. Suppose we are supposed to, let's say we are supposed to check that whether it is divisible by 35 square or not. Although here if we see 1 plus nx, if we write it in the form 1 plus x to the power n minus 1 minus nx, if we can write in that form, can we write it in that form? By 6 square, 6 to the power 2n, that means 6 square to the power n, that means 36 to the power n, that means 1 plus 35 to the power n. Right, now can we write it like this? 6 to the power 2n can be written as 1 plus 35 to the power n minus 35n minus 1. And we know that 1 plus x to the power n minus 1 minus nx is always divisible by x square. What is x over here? X is just 35, right? And we can prove it in the same way we proved our property. 1 plus x to the power n minus 1 minus x, nx is always going to be divisible by x square. Right, so main idea behind these problems is whichever term, whichever dividend you are checking, try to create the dividend in terms of your divisor. What is our divisor here? Divisor is 35 square. So try to convert your dividend in terms of divisor. That's it. So here also we did the same thing, right? Dividend, in this dividend we created in terms of 35. 6 to the power 2n we wrote in terms of 35. 1 plus 35 to the power n. And we know that 1 plus x to the power n minus nx minus 1 will always be divisible by x square. And here also this is going to be divisible by x square. Why? The reason you know, because this, if we expand this, what will we get? 1 plus 35c1 x to the power 1 plus 35c2 x square plus 35c3 x cube until 35 x to the power 35. Right, except from these two, all these terms, from all these terms we can take x square common. So, and minus 35n minus 1 is already there in the problem. So this will become what? 1 plus, what is this? This is 35 only. So 35x. Array, ulta, I'm writing here. Wait. This is n, right? So 1 plus nc1 x to the power 1, sorry, 35 to the power 1 plus nc2 35 square plus nc3 35 cube, and this will go till ncn 35 to the power n. And from all these terms we can take out 35 square common, and we have, in the end, we already have -1 minus 35n. Now this thing is becoming 35n, so 1 plus 35n plus all of this -1 minus 35n. So this and this will get cancelled. What will remain with? We'll just remain with nc2 35 square plus nc3 35 cube plus nc4 35 to the power 4 till ncn 35 to the power n. Right? From entire of this we can take out 35 square common. Inside what will remain? nc2 plus nc3 35 plus nc4 35 to the power 2, and it will go till ncn 35 to the power n minus 2. From all this 35 square can come out common, so that's why this is divisible by 35 square. We can simply say that, we can clearly say that without any trouble, without any confusion. Now next one also we can see 9 to the power 7 plus 7 to the power 9 is divisible by 64. What did I say? We'll try to create our divisor and dividend in the same terms. That should be our motive. What is 64? 64 is nothing but 8 square, right? So we'll try to, we can create these in terms of 8 square. What can I write? I can write 1 plus 8 to the power 7 plus 8 minus 1 to the power 9. Right? And because this is a odd power, I can also write minus of 1 minus 8 to the power 9. 1 plus x to the power n minus 1 minus x to the power n. This is that form. Right? If you want to expand also, you can check and expand. So this will just become 7c0, 1 to the power 7, 8 to the power 0 plus 7c. Although you should not, I don't recommend expanding, I recommend that you remember, but if you are doing it for the first time, you can expand so that you'll be well practiced. 7c1, 1 to the power of 7, 1 to the power of 6, 8 to the power of 1, right, plus 7c2, 8 to the power of 2, plus 7c3, 8 to the power of 3. It will keep going on like this. This will be like this. Minus, this will become what? Minus 9c0, 8 to the power of 0. So I can write 1 only over here, right? Is it okay if I write 1? So 1 minus 9c1, 8 to the power of 1 plus 9c2, 8 to the power 2 minus 9c3, 8 to the power 3. If you'll expand, you'll understand what I'm trying to say. Last term will be 9c9, 8 to the power of 7. So 1 minus 1 got cancelled. 7c1, 8 to the power 1 minus 9c1, 8 to the power of 1 will remain. Try to expand this once on your own. Now your 8 square will start coming out common from here and from here. So 8 square is there. You just need to worry about these terms. 1 and minus 1. This is also 1. This is also 1. 1 and minus 1 will get cancelled. Finally, we'll have 16 into 8. This will become 16 multiplied with 8. Okay. And your entire 64 plus your 8 square will come out common from all these terms. 7c2, 8 square plus 7c3, 8 cube, all these minus these, all these, 9c2 8 square minus 9c3, 8 cube, all these terms. From all these, 8 square will come out common. Now 16 into 8 is also divisible by 64, correct? 16 into 8 is what? 1 8s are 8, 6 8s are 128. Yeah, so it is divisible by 64. So this entire thing is this term is also divisible by 64. 64 into 2 only is written, right? This is 64 into 2, this is into 2, this is divisible by 64, and this entire thing is also divisible by 64. So it is proven that this 9 to the power 7 plus 7 to the power 9 is divisible by 64. Now here they can ask you what will be the remainder. Suppose if this term was not getting divisible, so this will behave as remainder. Right now everything is getting divisible, so remainder is just going to be 0 and nothing else. Try to observe this once on your own. Alright. Now if n be a positive integer, prove that. This you can do once on your own. Try to do it once on your own. Similar problem. Try to expand once and you'll be easily able to do. I'll show you. 3 to the power 2n plus 2 minus 8n minus 9 divisible by 64. 64 is what? 8 square. So we'll have to create everything in terms of 8 over here. For 8, first we'll have to create 9. Now 3 to the power 2n plus 2 is what? 3 to the power 2n into 3 to the power 2. That means 9 into 9 to the power n. Now this 9 to the power n can be written in terms of 8. 9 multiplied with 1 plus 8 to the power n minus 8n minus 9. Expand this. So 9 into 1 plus nc1 into 8 plus nc2 into 8 square minus 8n minus 9. Now when you see 9 into this entire thing will get cancelled, right? Minus 8n, this will get cancelled. Only thing which will remain is 8 square n plus nc2 8 square into 9 nc3 into 8 cube. All this will, only this thing will remain. From this we can take 8 square as common. That means that this is actually divisible by 64. Everything will get cancelled and from the remaining part of the expansion 8 square will directly come out common and you can say remainder is 0. This is divisible by 8 square. If there is some remainder coming, then you can use that remainder also, right? All right, try to do these problems once on your own. Just with the way how it's being taught, just solve them right now. If you're watching the video later, if you're watching it live, whatever it is, try to solve once on your own. Otherwise, it's all of no use. Prove that 13 to the power 2n plus 1 is divisible by 14. Now think about how will you create over here? What will you create over here? Now 14 you cannot write in term. 14 is not the power of any 14 is no power of any integer. So here in these cases you can create this 13 in terms of 14. You have to just write this term in terms of 14, right? For example, 13 itself you can write as 14 minus 1 to the power 2n plus 1 2n plus 1 plus 1. This you have to prove divisible by 14. So when you'll expand, you'll simply have simple expansion will come. I'll show you. 2n plus 1 c0, 14 to the power 2n plus 1, right? Minus, because this is x minus 1 to the power n expansion. So plus minus will go alternatively when you'll expand. From all of these terms, 14 can be taken out as common. Very simply you can see that 14 can be taken out as common and minus 1 plus 1 will get just cancelled. This minus 1 plus 1 will get cancelled because one term, first term will be plus 1. 2n plus 1 c0, right? So that term is getting cancelled. So for all integers, this entire thing is divisible by 14 and remainder is going to be 0. Right, this is how you're supposed to solve. Create this in terms, expand it, terms will get cancelled and you'll see that it is divisible. If there is some remainder, then remainder will also be visible to you. For example, this one, remainder when 3 to the power 63 is divided by 26. 3 to the power 63 is divided by 26. Now 3 to the power 63, how can you write? Just think of this. How can you create 26 over here? You know 26 is near 27. In 3 to the power 3 is 27. So that's your catch. 3 to the power 3 multiplied with 21. 21 into 3. 21 into 3 is 63. right? So 3 to the power 3 to the whole power 21 is 3 to the power 63. Here you can write 27 to the power 21, and this is nothing but 26 minus 1 to the power 21. Oh sorry, ulta I have written 1 plus 26, no? 1 plus 26 to the power 21. Expand this, right? 1 plus 1 plus 21 C1, 26 plus 21 C2, 26 square plus 21 C3, 26 cube, and it will keep going on till 21 C21, 26 to the power of 21. It will keep going on like this. Now divided by 26. When we'll divide by 26, what we'll have? 1 plus 26 can be taken out common from here itself. 21 C1 plus 21 C2, 26 plus 21 C3, 26 square will remain, and last 21 C21, 26 to the power 20 will remain. From all of this, 26 is taken common. Now if we'll divide this thing by 26, all this will get divided by, what will remain as the remainder? 1 will be the remainder. If some other number is remaining over here, that is the remainder. Very easy problems these are, right? You can easily solve these problems. These are not complicated. These just require little bit of practice, a little bit amount of practice. Okay, now next thing is finding the greatest term. Achha, this is solution, right? Finding the greatest term. In JEE Mains, this is not coming from last 1 or 2 years at least. This year also no question is from greatest term. Last year also I don't remember any question, but in advance it comes. There is a simple way of doing it. I'll teach you that way. Understand that method, how to find the greatest term, right? Apply that method in 2-3 questions and you'll be thorough with it. You'll be very much thorough with it. Okay. Steps. Suppose you are now how this method came and all, that is a different thing that I've taught in my earlier class of binomial theorem. If you want to know that how this method has appeared, how this method is coming, why are we using this method, then you can go check the description in the previous lecture of binomial theorem, which I took this year only, 2-3 months back. You can check that lecture on JEE English channel only. There I've taught how this method comes actually, but simple technique you can use. Suppose you want to find the greatest term in a plus bx to the power n. Some expansion is there, a plus bx to the power n, and in this you want to find which will be the greatest term. Now if you observe the expansion carefully, terms increase and then they decrease also, right? If you see the expansion of any binomial expansion, the value of terms first increases, then they decrease also. After a certain term, they start decreasing also. So in this, which one in this expansion, which one will be the greatest term? That's what we have to find. 3 steps are involved. First step, use this. Solve tk plus 1 divided by tk is equal to 1. Right? Solve for k. Over here, use tk, find k plus 1th term over kth term and put it equal to t. Put it equal to 1. Solve this. Tk plus 1 divided by tk, put it equal to 1, and here you find the value of k. You will get some value of k. Second step says if k is a non-integer, if k is not an integer, 6.3, 4.3, 5.3, 8.3, something like this, 8.5, something like this is coming. In that case, greatest term will be t, greatest integer function of k plus 1. Suppose if k is coming as 5.6, then t5 plus 1, greatest integer of 5.6 will be 5. t5 plus 1, that means t6 will be your greatest term. That's it. Simple. If k comes out to be an integer, then tk and tk plus 1, both there will be 2 greatest terms. If k comes out to be as integer, then tk and tk plus 1, 2 terms will be the greatest term. Both of these terms will be greatest terms. Most commonly, this case will come in your questions. Second case is also something which you should know, that tk and tk plus 1 both will be equal and they both will be greatest terms. If k comes out to be a non-integer decimal value, take the greatest integer function of k and that plus 1 will be your greatest term. Otherwise, tk and tk plus 1 both will be your greatest term. Let's try to do how we do it. Find the greatest term in the expansion of 2 plus 3x to the power 9 at x is equal to 3 by 2. So first we'll find the greatest term, and in the end we'll put x equal to 3 by 2. That's how. So first step says solve for tk plus 1 divided by tk and put it equal to 1. Right? This is our first step. You can check. First step was this thing. Right? So this will solve. Now here what will be tk plus 1? Tk plus 1 will be 9ck. Right? Tk plus 1 will be 9ck, 2 to the power 9 minus k and 3x to the power k. 2 to the power of 9 minus k and 3x to the power of k. This will be our tk plus 1. What will be tk? 9ck minus 1 will be tk. 2 to the power 9 minus k plus 1. Right? 9ck minus 1. Right? tk plus 1 is nck, x to the power k, y to the power x to the power n minus k, y to the power k. So that's why 9ck will come over here. Now 2 to the power of 9 minus k plus 1 will come over here, and 3x to the power of, this will be k minus 1. 3x to the power of k minus 1. 9 minus k minus 1. So 9 minus k plus 1 it will become. No? This you'll have to solve, and putting this will be obviously a little bit complex solution, but if you pay attention it will not be that much difficult also, because 9ck upon 9ck minus 1 you know how to solve. Right? This thing to you know na. 9ck upon 9ck minus 1, ncr upon ncr minus 1, n minus r plus 1 upon r. So that you are going to use. So this is just going to become 9 minus k plus 1 upon k. 2 to the power 9 minus k upon 2 to the power 9 minus k plus 1. Solve the other things. Right? 3 to the power k upon 3 to the power k minus 1 will become 3. Correct? And 2 to the power 9 minus k divided by 2 to the power 9 minus k plus 1. So 9 minus k minus 9 minus k minus 1. Right? So 2 to the power minus 1 it will become. So 1 by 2 and 3 to the power 2. 3 to the power 2 upon 2 to the power 2. That means only 9 by 4 will be multiplied. Solve this. Right? Simple. A to the power x upon a to the power y is a to the power x minus y. 2 to the power 9 minus k upon 2 to the power 9 minus k plus 1 will be 2 to the power 9 minus k minus 9 minus k plus 1. So 2 to the power minus 1. Right? 1, 2 also will be created from here, and 3 to the power 2 will be created from here. Okay. This is equal to 1. This you have to put equal to 1. Now solve for k. 4k will be equal to, so let me solve. 4k will be equal to 9 minus k plus 1. That means 5k is equal to 10, k is equal to 2. Are we getting k equal to 2? Check once. No, I think. Acha, we have to multiply also. Now wait, we didn't multiply 9. So it will become 4k equal to 90 minus 9k. Wait, it will become 4k equal to 90 minus 9k. So 13k is equal to 90. That means k is equal to 90 by 13. That means 6 point something. Right? 6.7 or 6.9. 6.9 something. Right? So k is non-integer. When k is non-integer, that means t of mod of k, sorry, greatest integer of k plus 1 is your greatest term. This is your greatest term. So t greatest integer, that means 6 plus 1, that means t7 will be your greatest term, and t7 you can easily find 9c6 2 to the power of 3 into 3x to the power of 6. This is what you are supposed to find at x equal to 3 by 2. This is what you are supposed to find at x is equal to 3 by 2. So this will become 9c6 into 3 to the power 6 multiplied with 3 by 2 to the power 6. Right? This will become 9c6 into 2 to the power 3, 8. Yeah, 8 will be there. 8 into 3 to the power 6 into 3 by 2 to the power of 6. This you'll have to solve and you'll get your answer. That's it. As simple as that. I think it should be there. Yeah, this only we are getting. So this will be 336 multiplied with 3 to the power 7. That simply you'll be able to solve the questions. Find numerically in the magnitude. Great. They can give you a question like this also, right? This you try to do on your own, or simply like 3 minus 5x to the power 15. Solve for tk plus 1 upon tk. First step, tk plus 1 divided by tk. Solve it equal to 1. What will be tk plus 1? 15. 15ck multiplied with 3 to the power 15 minus k multiplied with minus 5x to the power of k divided with 15ck minus 1, 3 to the power of 15 minus k plus 1 multiplied with minus 5x to the power of k minus 1. This you have to put equal to 1. So 15ck upon 15ck minus 1 will just become 15 minus k plus 1 divided by k. Right? 3 to the power 15 minus k divided by 3 to the power 15 minus k plus 1. This will just become minus k plus k, to 0. Right? And minus 1. 3 to the power minus 1. So divided by 3. Right? And minus 5 to the power k divided by minus 5 to the power k minus 1. So k minus k plus 1 minus 5 to the power 1. That means minus 5 only. So this will be minus 5 over here. And x to the power k divided by x to the power k plus 1. K minus 1. Right? So we'll have mod or this will become this x is getting cancelled. Minus 1 by 3. Mod of minus 1 by 3 we are getting, right? Over here. Minus 1 by 3 we are getting equal to 1. And here we'll solve for k. So I'll show you k. When we'll solve for k, it will come as k equal to 4. If k is integer, then t4 and t5 will both be your greatest terms. So you'll have to check both the terms which is greatest in magnitude. Both terms will be equal. T4 also if you find, which will be this. T5 also if you find, it will be positive. So in magnitude, both are same and equal. Both are greatest terms in magnitude. Magnitude wise, both are the greatest terms without any doubt. All right. Next thing. So this is how you find the greatest term. Now, yeah, this we studied, right? Greatest if n is even. Yeah. One more simple observation is there in the expansion in the coefficients. If they ask you which one is the greatest coefficient, the greatest coefficient will always be middle one. Right? Sometimes they might ask you which is the greatest coefficient. The greatest coefficient will always be the middle term. Always the greatest coefficient will be the coefficient of middle term. So if n is even, n plus 1 will be the number of terms, middle terms will be just 1, and you know how to find the coefficient of middle term, right? If n is odd, then number of terms will be even. In that case, there will be 2 middle terms and 2 middle coefficients, both will be greatest. This is another catch, right? If n is rational, binomial theorem for any index. This we should not actually study. Just remember these small things, right? 1 plus x to the power minus 1, if you want to expand, its expansion is simple. 1 minus x plus x square minus x cube, and it will go like this. 1 minus x to the power minus 1 will be 1 plus x square plus x cube. Minus here, just remember like this. If minus minus, it will become plus. All the coefficients will be plus, all the signs will be plus. In case of plus into minus, it will be minus. So 1 minus x plus x square minus x cube, and it will go on like this. Final one will be minus 1 to the power r, depending on r is even or odd, right? Till where we are expanding. This is infinite expansion. It is an infinite expansion. It will keep going on like this, because here x is between minus 1 and 1. That's the catch. Sometimes if x is very small, then these expansions you should remember as it is. 1 plus x to the power minus 2 plus minus, so minus plus Plus into minus is minus, so minus 1, minus and plus will be alternative. 1 minus 2x plus 3x square minus 4x cube plus 5x to the power 4. It will go on like this. 1 minus x to the power minus 2 will be expanded. Minus minus plus, so all will be plus. 1 plus 2x plus 3x square plus 4x cube plus 5x to the power 4. This goes on like this. Remember, small things very rarely used, but directly sometimes these expansions can be useful. This is called binomial expansion of any order, of any index. This is not a different concept. Only based on these expansions we do this. For example, try to attempt this question. If 3x is between mod of 3x is less than 1, that means 3x is between minus 1 and 1, right? This term should be very small. In that case only we can have a binomial expansion of any index. So what will be the coefficient of x to the power 2 in this? Try to find it out. Basically, I'll give you the idea. This is what is written over here. 1 minus 2x to the power minus 1 multiplied with 1 minus 3x to the power minus 1 is written over here. Right? So 5 is going to remain outside. If we expand this part, 1 minus 2x to the power minus 1, minus minus plus, all the terms will be positive. 1 plus 2x plus 2x square plus 2x cube. This will keep going on, right? And if we expand this, what will this be? 1 plus 3x plus 3x square plus 3x cube, and it will keep going on. As simple as that. Okay. You are supposed to find the coefficient of x square. So x square coefficient. Now see how will x square be created? 1 multiplied with 3x square, that will create one coefficient, that will create x square. 2x multiplied with 3x will create x square. 2x multiplied with any other term will not create x square. 2x square multiplied with 1 will also create x square. Right? So club all these. That's it. You will get the coefficient simply. Try to check which all will be the coefficient. 1 multiplied with 2x whole square, right? 5. So coefficient, try to find out the coefficient of x square. 1 multiplied with 4x square or 1 multiplied with 2x whole square is also given 1, and 4x square I am writing. This is giving you coefficient of x square. How else can we get? 1 multiplied with 9x square will also give us, that means 3x whole square will also give us x square, right? So 1 multiplied with 3 or I can write 9x square will also give us x square. Then 2x multiplied with 3x is also giving us x square. Then 2x and 3x is also giving us x square. 2x multiplied with this 3x. Any other way in which we are getting x square? 2x square multiplied with 1 is giving us x square. 2x into 3x is giving us x square, and 3x square multiplied with 1 is giving us x square. Only these cases we are getting x square. So coefficient of x square will be nothing but 4, 9 and 6. 4 plus 9 plus 6. Right? So 4 plus 9 plus 6, from 4 here, 9 here and 6 here. This will be coefficient of x square. This whole is multiplied with 5. So entire coefficient will become 5 multiplied with 4 plus 9 plus 6. That means 19 into 5, that is 95. 95 will be your coefficient of x square in this particular expansion. As simple as that. This is how you are supposed to solve these type of problems. Okay ji. Try to solve this. Find the coefficient of x cube. There is division now. You'll have to be a little bit smarter. Right? Coefficient of x cube. No need to be smart. There is nothing like that also. Just write it in the form in which you can expand. Whenever this thing is given, no, that means they are asking about expansion of any index. 1 plus x to the power minus 1 or 1 minus x to the power minus 1. Something like that they are asking. Right? Or minus 3 sometimes. Right? Minus 3 sometimes. So here we have 1 plus 3x to the power of minus 3. So if you observe these expansions carefully, which I showed you, 1 minus, what do we have? In the question we have 1 plus 3x, right? So here compare it with 1 plus x to the power minus 2. What are we getting? What will be the coefficients? Try to expand this. Observe carefully. Try to do this on your own once. Just try to expand 1 plus 3x to the power minus 3. First term will be 1. Next term will be minus 3 into 3x. Right? Minus 3 into 3x. Then minus 3 into minus 4 upon 2 factorial. That means 3c2 multiplied with 9x square. 3 into 3x square. Correct? So I'll show you. If you have observed this, we are just expanding this. Try to expand this. It will be 1 minus 3 into 3x, that means minus 9x, plus minus 3 into 3c2 minus 4 into 2 factorial into 9x square, minus 3 into minus 4 into minus 5 upon 3 factorial, 27x cube. This will be the expansion. Try to expand this once on your own. You'll see the expansion very clearly. Now 3 minus 2x is here. All these values, when you solve this, this will come out like this: 1 minus 9x plus 54x square minus 270x cube, and it will keep going on like this. Coefficient of x cube will be obtained when you multiply 2x with 54x square. Right, and 270 with 3. That's it. 273 with 3 and minus 2 into 54. This will be your coefficient of x square. That's it. You just have to see how x square will be created, nothing else. Multinomial theorem, nowadays it's not there in your syllabus, but still I'll tell you. So basically x plus y plus z to the power n, multiple terms are there. In that case, your expansion is sum of all these terms: n factorial upon r factorial, s factorial, t factorial, x to the power r, y to the power s, z to the power t, where r plus s plus t is always equal to n. Right, where r plus s plus t is always equal to n and are non-negative integers. So number of terms, for example, there is an expansion over here. Number of terms in the expansion of n, x plus y plus z to the power n. This thing you should remember. On the basis of this, sometimes questions are asked in JEE which says that number of terms in this expansion will be n plus 2 c2. This is a different expansion. This is not binomial. This is multinomial. Although now this is not in your syllabus, but still remember this basic, that it's just sum of all these terms: n factorial upon r factorial, s factorial, t factorial, where r plus s plus t is always equal to n, and these are the powers. This much also, if you remember, no, you'll be able to attempt the question even in advanced if it comes from this. Questions like this: number of terms, find the number of terms in this x to the power 4 y find the number of terms in this and coefficient of x to the power 4, y to the power 10, z to the power 3. So number of terms, we know, we can easily find. Number of terms are just going to be, just now we learned, no, n plus 2 c2. So number of terms will be 17 plus 2 c2. That means 19 c2. So part A, this is just going to be 17 plus 2 c2, which is 19 c2. This also, if you remember, number of terms is going to be this much in a multinomial. That means if 3 terms are there. This type of question has been asked in JEE, not in recent years, earlier. But yeah, they can, I think, even after excluding this part, they might ask you this type of easy question in JEE also. So be prepared for it. Now, coefficient of x to the power 4, y to the power 10 and z to the power 3. They have given the powers. Right? You know the formula. What will it be? 17 factorial, n factorial divided by r factorial, s factorial, t factorial. That means 4 factorial, 10 factorial, 3 factorial. That's it. Right? What will be the terms? These will be the terms. This will be the coefficient of x to the power 4, y to the power 10 and z to the power 3, right? X plus y plus z are always equal to 17 over here. Sorry, r plus s plus t are always equal to 17 over here. So the coefficient will be nothing but 17 factorial upon 4 factorial upon 10 factorial. Sorry, this will be your coefficient, 17 factorial divided by 4 factorial, 10 factorial, 3 factorial. This will be the coefficient of x to the power 4, y to the power 10, z to the power 3. These basic type of questions you should know about multinomial theorem also. Nothing more than that for JEE for now. Same way, x to the power 3, 8, y to the power 8, z to the power 2. Huh? There will be no such term, right? There will be no such term because in multinomial, check, this is also special case, 8 plus 2 plus 3 is not 17. So in a multinomial theorem, always r plus s plus t should be equal to n, which is not the case. So there will be no such term. There will be no such term. So coefficient, if they are asking you, coefficient will be 0. There will be no such term because 3 plus 8 plus 2 is not equal to 17. So there will be no such term. Hi Priya, how are you? All good? Having fun? Okay, there will be no such term. Coefficient will be 0. This we already learned. 1 plus x to the power n. Basic expansions. This we already saw. Some important more properties. Now in this expansion also becomes an identity. When we know 1 plus x to the power n can be expanded like this and expansion will always be same. This also actually is an identity, right? You put any value of x, it will be true, right? If I put x equal to 1, what do I get? nc0 plus nc1 plus nc2 plus nc3. So sum of all the coefficients will be equal to 1 plus 1, 2 to the power n. That means 2 to the power n. Just now we studied about identity and this also becomes an identity. That's why you can put any value of x. Right? So sum of all these coefficients will become equal to 2 to the power n. If you put x equal to minus 1 or here if you put x is equal to minus 1, what do we get? nc0 minus nc1 plus nc2 minus nc3. All these. This is the expansion. Put x equal to 1 over here. Put x equal to 1 over here. So sum of nc0 minus nc1 plus nc2 minus nc3. This will come equal to 0. Right? So this we have already done. In the questions related to this part, we have already done. Whenever you have an identity, both sides of equal to are given to you, use the values of x as 1 and minus 1 when you have to find sum of coefficients or a series of coefficients. In that case, use the value of x as 1 or minus 1. You will always get your answer. You might have to do some manipulation. All right, next thing. In binomial coefficient problems, right? So let's see binomial coefficient, some sort of binomial coefficient problems also. So based on this only, we do this, right? 50C25 plus 49C24, right? Till 25C0. 25C0. Last one is 25C0. So here you'll have to use some initial properties of coefficients which we learned in the very starting. For example, NCR plus NCR plus 1 will be NCR, N plus 1, CR plus 1. So NCR plus NCR plus 1. Can we see over here? NCR plus N plus 1 CR plus 1. Or something else. Is this the same? Is this the same? NCR plus NCR plus 1. Can we create that scenario over here? Try to create that particular scenario over here and you'll be sorted. Now see, last one is 25C0. If you look, last one is 25C0. Now 25C0, if you see 25C0 plus 26C1, what will this become? NCR, ulta I'm writing, kya? 25C0 will be 1 only, huh? 25C0 plus 26C1. Can you use this over here? I don't think you can use this over here. But if 25C0, instead of 25C0, if I write 26C0, does it matter? NC0 is always 1. NC0 is always going to be equal to 1. So 25C0 or 26C0, it's 1 only. But one thing is changing. When I'm writing 26C0 plus 26C1, this form is being created. NC0 plus NCR plus NCR plus 1, which is going to be equal to N plus 1, that means 27C, R plus 1, that means 27C1. Correct or not? Try to connect this, just give me a minute. My health is not very well. I'll just be back. Yeah. Now see, I'll explain once again. See, this last term is 25C0. So I want to add all of these. 25C0 plus 26C1 plus 27C2 plus 28C3. This is what we are doing till 50C25. This is what we are doing. Okay, now pay attention. If instead of 25C0, I told you that write 26C0 because both are same. Now these two will give you what? 27C2, applying this property. 27C1, applying this property. NCR plus NCR plus 1 will be N plus 1 CR plus 1. So this will become 27C1. 27C1 plus 27C2 plus 28C3 plus 29C4 till 50C25. We have to go. Now these two will give us what? 28C2. Then this will combine and it will give us 29C3. Then 29C3 plus 29C4 will be 30C4. 30C4 plus 30C5 will be 31C5. So this will keep going on, and the last term which will come out to us is 51C25. This will come. Final sum will be nothing but 51C25. This is how you have to solve these type of problem. Let's see a couple of more. This is why are these texts disrupted? I'll have to check. 11C5 it is. This should be 11C5. Now think, what can you do? 15C8 minus 14C8 minus 13C7 minus 12C6. Again, make the use of this. Now same property, NCR plus NCR plus 1 is N plus 1 CR plus 1, or what I can say, N plus 1 CR plus 1 minus NCR plus 1 is equal to NCR. N plus 1 CR plus 1 minus NCR plus 1 is also equal to NCR. Now when you have minus, you can do this. Now check. Try to do with the second property. So 15C8 minus 14C8 is going to give us what? N plus 1 CR plus 1 minus NCR plus 1. Right? We know this property. NCR plus NCR plus 1 is going to be N plus 1 CR plus 1. We know this. N plus 1 CR plus 1. This I keep one side. This I subtract. Minus NCR plus 1 is equal to NCR. So I have to, why did I make this manipulation? Because this R was same in the questions and this was decreasing. So that also I can do, right? N is decreased by 1, R is same. Will give us NC3. That means smaller one. That means 14 NCR. NCR. This is R. Right? This is R. So what do you have to do? 50. Smaller one will have to take. Smaller one will have to take. N plus 1 is 15. N is 14. R plus 1 is 8 only. R plus 1 is 8 only. So NCR will become what? Just try to compare. It will become 14, the smaller one. C, R plus 1 has decreased by 1. So 8 will be decreased by 1. That will be 14C7. So this term will become 14C7. And if we'll combine these two, 14C7 minus 13C7, what we'll get? 13C6 we'll get. And then 13C6 minus 12C6 will give us 12C5. 12C5 minus 11C5 will give us 11C4. So final answer will come nothing but 11C4. This is how initial properties, on the basis of those properties also you might get some questions. So remember those properties, all these examples are same using those properties only. Sum, binomial coefficient sum, binomial coefficient sum. So NC0 plus NC1, all the coefficient sum is 2 to the power n. NC0 plus NC2, even coefficients will be equal to sum of odd coefficients, and that will be equal to 2 to the power n minus 1. You know that sum of all coefficients NC0 plus NC1 plus NC2 plus NC3 till NCn, if we sum all these coefficients, this comes out to be 2 to the power n. But if you only want even coefficients, right, even coefficients, this is just expansion of 1 plus x to the power n, where we are putting x equal to 1. So you know NC0 plus NC2 plus NC4, right, NC4 plus NC6, right, this will be equal to NC1 plus NC3 plus NC5, all the odd coefficients. Sum of all even coefficients will be equal to sum of all odd coefficients. This is because of expansion of 1 minus x to the power n, where we are putting x equal to 1. So this will be equal to 2 to the power of minus 1. Remember this. Here we are summing up all the odd coefficients. So it will be equal to 2 to the power of 23 minus 1, that is 2 to the power 22. This sum will be nothing but equal to 2 to the power of 22. Remember them as it is. Small manipulations, but it's better that we remember them. Again, same type of problem, 20C0 minus 20C1 plus 20C2. So we know the expansion, right? Both will be equal, that's why both will be doubled. Even and odd both are there, so that's why sum will be doubled, which will be equal to 20C10, and this expansion, so half of 20C10 will be only for this part, where we are only taking 1 minus x to the power n expansion. This is 1 minus x to the power 20 expansion, all the coefficients of that. Check these solutions. I'll put it in the I'll put these in your notes, so no worries. Now try to solve this. This question came this year. This question is this year's question only. Sum of what is it saying actually? Sum of all the values where r is increasing from 0 to 7. So basically 7C0 divided by 2C2 plus 7C1 divided by 3C2 plus 7C2 divided by r, if r was 1 over here, 2, so 4C2 plus 7C3 divided by 5C2. This is what we are doing. This expansion till 7C7 divided by 9C divided by 9C2. This is what you are finding, which you can easily find actually, right? You can easily find. Otherwise, one more method is there. Solve the part which is there inside sigma. You can also solve the part which is there inside sigma. You can do this way if you want to add the series, or one more better approach for these type of questions is solve this part which is inside the sigma, which is 7CR divided by r plus 2C2. That means r plus 2 factorial by r factorial into 2 factorial. So this will just become 7 factorial divided by r factorial multiplied with 7 minus r factorial over r plus 2 factorial divided by r factorial into 2 factorial. So I think r factorial you can cancel just like that. So this will become you can solve like this. 7CR upon r plus 1 into r plus 2 it will become. It will just become 7CR into r plus 1 into r plus 2. right? When you're solving this, RR is getting cancelled and this is coming as 7CR on R plus 1 multiplied with R plus 2. Here you can put the values and find the sum. Here you'll have to use APGP, sum of arithmetic progression, or mostly sum of arithmetic progression only you'll get to use over here in these type of questions. Otherwise, if denominator is coming same only in all the cases, then add the numerators. So very simple type of problems. Method is try to solve the inner part and then sum the terms. Use sum of AP, or just directly open and check what is it becoming. Hi sir, good afternoon. Good afternoon, Rita. What is it becoming? Some more results which are rare. This one is, I'll tell you which one are important over here. This one, very important. Then this one, very important. These two. Although in mains, if questions come directly, they might come on the basis of these formulas. Very simple, basic formulas, direct application. So remember, sum of R NCR from 1 to n will be n into 2 to the power n minus 1. Sum of R square NCR will be equal to n into n plus 1 into 2 to the power n minus 2. Note them down somewhere. Remember them as it is. This is not very useful. Sum of NCR upon R plus 1, very rarely, very rarely 1% chance that this can come. But you can keep a note of this. The sum will be equal to 2 to the power n plus 1 minus 1 upon n plus 1. Two more are there. Sum of NC n minus R, sum of product of NC n minus R into NC R plus K, where R is increasing from 0 to n minus K. This is not even, you don't need to actually remember this. This won't come. This you should remember. Sum of NCR square. Direct question has come in 2024 from this formula. So it's better now if we remember these formulas. Sum is also very simple, 2NCN. Sum is also very simple, 2NCN is the sum. Direct question can be asked on these formulas. So this is all. Practice binomial theorem a little bit, practice all the varieties of questions. It's just about expansion. Revise this chapter, revise the questions, try to solve the questions which you have done already, right? Also, as I told you about the JEE Nexus channel, about the Arambh event which is going to happen in March, we are going to plan on launching some batches, especially for 2025 and 2026 aspirants, where they can study in English completely. So that's all these informations, all these surprises will be on 1st March. The link is there on JEE Nexus channel and on English channel also. But I recommend you to go on JEE Nexus channel and see a couple of things which are already being revealed, right? This will be live in 10 days. 1st March is going to be the event. But so click on notify me button so that you'll be notified about this event very quickly. Otherwise, you'll miss this part. And it's an important event for everybody. All right. So I think I should take my leave. The practice of binomial theorem will be doing on Friday. The link of the practice session, which will be there on portal, it will appear on the in the description of this particular video only, right? So you can click that. Just click on enroll and you'll be enrolled, so that I'll already know these many students are coming and I'll come up with questions. Try to attempt these practice sessions. These are going to be really important for you all. We'll be practicing many problems from entire algebra. First, we are trying to finish up the algebra part. So that's all. All right. Practice this. Have fun. Take care. Bye-bye. All the best.